Hello everyone. Today I am Sahana Kulkarni. Today again we are going to discuss with the chapter wave optics, that is the session 4th. So in this case today we are going to discuss regarding the principle of superposition. Already in first PUC you have studied this. This is the principle of superposition. So if two or more waves they are superimposed on one another, resulting into the new wave which has a resultant displacement at any instant equal to the vector sum of the displacements due to the individual waves at that instant. So according to which at a particular point in the medium the resultant displacement produced by the number of waves is the vector sum of the displacement produced by each of the waves. So for that we will consider the two waves, that is let y1 and y2 be the displacements of these waves, that is particles respectively, at an instant caused by the waves. Then the resultant displacement, generally we can write it as it is in the vector form, that is vector form y is equal to, it is y1 plus or minus y2. Means if two or more waves, if they are superimposed on one another, that will be given by the vector sum of the individual displacements. So for this now we can study what is meant by the constructive superposition. So constructive superposition means when two waves of same wavelength are superimposed on one another in phase. In phase means crest of one wave falls on the crest of the other wave, as well as the trough of the one wave falls on the trough of the other wave. Then this superimposition is called as constructive superimposition. Then the resultant displacement will be given by, that is y is equal to y1 plus y2, that is a vector form, y is equal to y1 plus y2. And in constructive superimposition or the constructive superposition, intensity of the wave which is directly proportional to the resultant amplitude, that is square of the resultant amplitude. So in this case what happens, the amplitude goes on increases, the resultant amplitude will be increases, and that will be given by, that is in constructive superposition, the intensity of the wave which is directly proportional to the square of the amplitude, that is I is directly proportional to the square of the amplitude. This can be understood with the help of the diagram now. So just you can see here that y1 it is one wave, that is, and similarly y2 that is a displacement of another wave. So both will superimpose. Here what happens, the crest of the one wave falls on the crest, as well as trough of the another one wave falls on the trough of the another wave. So the resultant displacement, that in figure you just observe, the resultant wave or the resultant displacement that will be added up here, that is y is equal to y1 plus y2. So this is regarding the constructive superposition. So whenever there will be the crest of the one wave falls on the crest, as well as trough of the one wave falls on the trough, then the resultant displacement will be added. Then both the displacements will be added. Next we can discuss regarding the destructive superposition. So when the two waves of same wavelength superimpose on each other but out of phase. Out of phase means that is crest of one wave fall on the trough of the other wave, and vice versa. Similarly trough of the one wave falls on the crest of the other. Then the superimposition or the superposition is called as destructive. And this case the resultant displacement, again the resultant displacement we can write it as it is y is equal to y1 plus of minus y2, because here the resultant displacement, the amplitude goes on decreases. So that in destructive superposition, the amplitude and the intensity of the resultant wave that will be goes on decreases. And this will be understood with the help of a diagram. So just in diagram you observe, first one is y1, that is the displacement of one wave, and second one is the y2, that is the displacement of the another wave, and the middle one, just you observe, that is a resultant of the displacement of the resultant wave. Means in this case the crust falls on the trough or the trough falls on the crust, automatically the displacement, that resultant displacement will be decreases. Next we are going to discuss regarding the interference of light. So interference means it is the distribution of the light energy due to the superposition of two or more waves of the light. It is called as interference of light. So how this light energy will be distributed in case of the superposition? Already we have discussed, in constructive superposition it will be added up, and in destructive superposition you can take it as it is in subtraction. So how this distribution of light energy it will be taken place in the superposition of two or more waves of that light is called as it is an interference of light. And because of this interference there will be alternate dark and bright regions are observed, and they are called as interference bands or interference fringes. So this is very important. So how this light energy will be distributed, and because of that we can get it as alternate dark as well as bright regions. So sometimes we can get it as it is a dark, and sometimes we can get it as it is bright, and they are observed, and they can call it as it is an interference bands, or generally we call it is interference fringes. And interference can occur only with a coherent source. So main theme or main, when you get the interference, the source must be the coherent source. So this we will going to discuss regarding the coherent sources. Coherent sources means if the two sources of light, they are said to be coherent if they emit the waves of same frequency or the same wavelength, and are either in phase or have a constant phase difference. So if two sources are said to be coherent, then they must be having the same frequency, or we can call it as the same wavelength, and they must be in the same phase, or the phase difference must be the same. Then they are called as the coherent sources. And the two independent sources cannot be coherent even though they have, or even though they emit the waves of equal frequency or the equal wavelength, but they may not have the constant phase difference. So you may ask, that is, suppose the example, if the two 60 watt bulbs we have taken and they will emit the sources, then can they coherent? So answer is no. So two independent sources, they cannot be the coherent. Even they emit the same waves as well as same frequency as the same wavelength, but the constant phase difference will not be possible whenever the two individual sources if you have considered. So therefore, to obtain the interfering beams, a single source is used and its beam is split up into the two different ways, and they can be done with the help of the division of wavefronts as well as with the help of the division of wavefront. So coherent sources means they must have the same wavelength or the same frequency, and they must in the phase or the constant phase difference. And remember, there will be no two individual sources are the coherent. So only one single source we are using. So we are dividing, or you are splitting that source into that beam into the two different ways. One is by division of wavefront and another one is division by amplitude. And next we are going to discuss regarding the explanation of coherent sources. So for that we will consider the two needles S1 and the S2. In diagram just you observe that S1 and S2 are the two needles which are moving periodically up and down in the water, and they produce two waves each of amplitude A at an instant, and the phase difference between their displacement does not change with the time. So here there will be no phase difference in this case. So just to observe in the diagram, that is in water the waves are produced. Here I will take the 2 points, that is S1 and S2 are the 2 points in the waves, and similarly I have considered a point P such that S1P and S2P are equal, that is S1P equal to the S2P. So that is we will take the next part, that is consider a point P such that S1P must be equal to S2P. Already you have seen in the diagram. Then the resultant displacement that will be given by, generally we know y is equal to, it is y1 plus y2, because it is in coherent sources, that is constructive displacement. Therefore, but what is our y1, the displacement? In first PUC you know regarding this, that is y1 is equal to, it is a sin omega t, and similarly y2 is also equal to a sin omega t, because there is a no phase difference in this case. Then substitute the values, that is y is equal to a sin omega t plus a sin omega t. Then our resultant displacement y is equal to, it is 2a sin omega t we are getting. Similarly, consider one more point, that is P dash, where that, so just observe in the figure, that is S1 P dash which is not equal to S2 P dash. S2 P dash which is greater compared to the S1 P dash. So in the waveform just to observe, so S1 P dash is not equal to S2 P dash. Therefore, I can write it as it is S2 P dash minus S1 P dash is equal to lambda. Lambda means one full wavelength, that is a wavelength. So in the diagram, S1 P dash is one full wave. Similarly, S2 P dash is two waves we are getting. So one wave that will get cancelled. So extra one is the wavelength, that is lambda. See in the diagram, that is the wavelength lambda. Therefore, our difference will be S2 P dash minus S1 P dash is the lambda. Next, then y1 is already we know, that is a sin omega t. Yes, of course here the phase difference is occurred. Then our y2 is equal to, which is not equal to a sin omega t, it is a sin omega t plus 2 pi. 2 pi is nothing but, that is the phase difference which is corresponding to lambda. Lambda means it is one full wave, or we can call it as this lambda is equal to the 2 pi radian. Therefore, our y2 is equal to a sin omega t. How you are getting this y2 is equal to a sin omega t? Just to observe here, that y2 is equal to a sin omega t plus 2 pi, whatever you are getting. So this sin omega t plus 2 pi, it is in the form of sin 2 pi plus theta, that is sin omega t plus 2 pi, or we can call it as it is sin 2 pi plus omega t. Omega t is nothing but the angle here we have considered. So sin 2 pi plus theta. So what is sin 2 pi plus theta? It is in the form of sin A plus B. Sin of A plus B. Sin of A plus B means it is sin A into cos B plus cos A into sin B. So sin A is sin 2 pi into this cos theta plus cos 2 pi into sin theta. So what is sin 2 pi? Sin 2 pi is 0, cos theta as it is, and similarly cos 2 pi is 1 and sin theta is as it is. So 0 into anything gives you 0 itself. So our answer is sin theta. So with the help of this, the answer is sin theta. So according to our equation, our y2 becomes a as it is. Sin theta is nothing but sin omega t. So y1 is equal to a sin omega t we got, and similarly y2 is equal to a sin omega t here we got. Then our resultant displacement that will be given by y is equal to y1 plus y2. So add these two, that is a sin omega t plus a sin omega t. We are getting again y is equal to 2a sin omega t. Hence the intensity is increased, and the superposition here we can call it as it is constructive superposition. In the previous lecture we know regarding the constructive superposition, whenever the intensity or the amplitude goes on increases, then we can call it as it is a constructive superposition. Similarly, next we can consider one more point, that is P double dash. In the same diagram, just you take, that is a P double dash. So again, just you observe in the diagram, so S1 P double dash which is not equal to S2 P double dash. So again in the form of wave we will take, that is S2 P double dash minus S1 P double dash is equal to lambda by 2. So just in diagram you just observe, that is S1 P double dash is a one full wave, that is a lambda. Similarly S2 P double dash, it is one full wave and remaining is the half. So one full wave get cancels with each other, remaining is half, means lambda divided by 2. Therefore we can consider it as lambda by 2. Then again consider the equation, that is y1 is equal to a sin omega t, and similarly y2 is equal to what? A sin omega t plus pi. Pi why you are consider means the phase difference which is corresponding to lambda by 2, half of that. So one full wave you have consider it as 2 pi. So now half of that lambda by 2 means it is pi radian. Therefore again y2 is equal to, we can get it as it is minus a sin omega t. How it is minus a sin omega t? Again we'll come to this. That is y2 is equal to a sin omega t plus phi. That omega t plus pi is nothing but it is sine of pi plus theta form. So therefore our y2 is equal to a sin omega t plus phi, that is nothing but sine of pi plus theta form. Therefore this is again it is sine of a plus b form. So sine of a plus b means again sine a into cos b plus cos a into sine b. So sine a is sine pi into cos theta plus cos pi into sine theta. What is our sine pi? Sine pi is 0 and cos theta as it is plus cos pi, cos 180, that is minus 1 into sine theta. Therefore our answer is 0 into anything gives you 0. So that is minus sine theta. So minus sine theta is our answer. Therefore we are getting it as minus sine omega t. Therefore our y2 becomes minus a sine omega t. Then again the resultant amplitude that will be given by, so y is equal to y1 plus y2. Therefore y is equal to, it is a sin omega t minus of a sin omega t. Then you are getting the y is equal to 0. So whenever you are getting the 0 amplitude or intensity, it is called as destructive superposition, means automatically the intensity or amplitude goes on decreases. So this is what regarding the explanation of the coherent sources. Thank you everyone.